in section 2.2. And in section 2.2, what they're going to do is they're going to talk about reference angles. So remember that the first chapter we did, it was all the points in a quadrant, and then we went to right triangle trig, and that was only essentially first quadrant trig. Now what we're going to do is we're going to talk about the angles. So it's not points, it's angles now, where your initial side's going to be the same thing as we always have been dealing with in terms of initial side. The initial side is all, oops. You guys can't see that? Nobody said anything. I can see it. I don't understand that. Well, I can get caught up on my. All right, so here our initial side of our angle is going to be here, just like always. It's the positive x-axis, and then our terminal side is going to be wherever. And what we do is we talk about a reference angle. If we're in the first quadrant, then the angle is the reference angle. They're one and the same. If we're in the second quadrant, and that's here. Now, the angle that we're going to be talking about is this angle right here. But we're looking at a reference angle, and a reference angle is always the angle between the terminal side and the x-axis. So it'll be the reference angle for this one. I'll call this theta 2 prime. So we know what this is theta 2, and then this would be theta 1. So if you're in the first quadrant, then the angle is the reference angle. If you're in the second quadrant, the reference angle is this one. And what you do is you do your trig functions off of this one, off the reference angle. And the common mistake, and they're going to tell you here, is to make the reference angle this angle. For example, if we have, obviously anything between 0 and 90, it's just your trig functions are going to be just, remember the common ones are 30, 45, 60, 0, and 90. So that's pretty easy here. But when you get over here, for example, if you have this angle is 150 degrees, then when you do your trig functions, you take 180 minus the 150, and you got 30 degrees. So then you'd go sine of 30 would be 1/2, right? And the sign is positive in that quadrant. Just as the signs for the quadrant are negative in this quadrant, positive. Whether it's plus or minus. So, and what you have is the cosine is always related to the negative, right? And the sine is always related to the positive. So what we do is we say here it's plus, plus. So the cosine's plus, the sine's plus, right? In this quadrant, the cosine's minus, the sine is minus, plus, excuse me, in that quadrant. When you're down here, because the x and y is negative, negative, then the cosine is always related to the x, so it's negative in that quadrant, and the sine is negative. You see what I'm doing? So if we're in this quadrant, and if we had 150 degrees was the angle, our reference angle is 30. So we'd say the sine of 30 is a positive 1/2 in that quadrant. The cosine of 30 is going to be a negative square root of 3 over 2. Right? Because that's sine and cosine. And then the rest of them are related in that fashion. Using what I always think of as then you use your trig identities, the tangent equals sine over cosine and so on. Now if you're down in this quadrant down here, let's just, you can see the angle is going to be an angle like this, and it's going to be angle from 180 to 270 degrees. Now its reference angle is going to be this angle. It's always back to the x-axis. Now if you have an angle down here, you can see that the angle that we're going to be dealing with, the angle we're dealing with is down here like this, but our reference angle is going to be here. And then it's going to have these, the signs are going to be, x is going to be positive, y is going to be negative, so our cosine is positive and our sine's negative in that quadrant. And then whatever this reference angle is, and do you see the reference angles are always going to be what? Between 0 and 90 degrees. See that? It's always 0 to 90 because all of these angles, if it's a reference angle, the highest it could be when it's in this quadrant is 90 degrees. And when it's this quadrant, the highest it could be is 90 degrees. When it's in this quadrant, reference angle can be up to 90 and here, up to 90. Don't make the mistake of having the reference angle be this one or this one up to the y-axis.
What specifies what quadrant reference angle is in when it's
be the terminal side of your angle. See, the angle we're dealing with, if we're in the first quadrant, is this angle here. The angle in the second quadrant is the angle from here to there. Where the terminal side will tell you, where you're going to go reference angle.
if it's like between quadrant 3 and quadrant 4, like 90 degree y-axis.
Then it's a quadrantal angle. It's on the quadrants. See, like what you're saying is it's 270.
Yes.
Well, then it's going to be a 90 no matter which way you go, right? If you think about it in this quadrant, it's 90. Think about it in this quadrant, it's reference angle, it's 90.
So it's a 90 for the it doesn't have a reference angle.
Yeah, it doesn't. But the only thing is when we go to waveform trigonometry, you will have a sine of 0 degrees or a sine of 90. We'll have at a sine of 0 degrees will be 0, and the sine of 90 will be 1. And then what it does, it goes, if you're talking about sine, it's 0 here, it's 1 up here, it's back to 0 here, then it goes to a negative 1, and then it goes to 0. Does that make sense? See, and when you go waveform, if you think about it, it starts out at 0. If you're going height, it goes 0, goes up to 1, down to 0, down to -1, and waves back. And if you ever seen a heart monitor, it has it's kind of jagged, but it's a sinus rhythm, and that's a sine curve. That's why they call it a sinus rhythm, because it's sinusoidal in nature, and it's a sine curve. And then it has the other trig functions. you know, if it goes wild and goes, it can turn in from a sine curve to a cosine curve to a tangent to secant. There's all those curves, and it'll register out if your heart goes crazy, you know, it does things. And you know, oscilloscopes of any kind are just running out trig functions. Running this whole thing out that we're doing here out into a straight line, just unfolding it. We'll talk about that. That's where there's all these different methods of doing trigonometry. There's quadrant where you have a point. There's right triangle. And you see this is kind of related to right triangle. See, it's just actually establishing a reference triangle in a reference quadrant. But it always goes back to the x-axis. You notice on page 59 that caution. Be sure. See, if you have 120 degrees, what you have to do is 120 degrees is in which quadrant? First, second, third, or fourth? It's in the second quadrant. Now, how are you going to get the reference angle for 120? 180 minus. Now, if you're down in this quadrant, let's just say we're at 230 degrees. Now, where are we at? We're in this quadrant. So now how do we get the reference angle? 230 minus 180, right? 50 degrees. So sometimes you'll be subtracting the angle that you have, the terminal side, from 180. Sometimes you'll be subtracting 180 from that. The reference angle always is the terminal side back to the closest, you know, x-axis. Don't do it over to the y-axis. And that'll be a common error that you'll run into. If you go back to the 120 example, if you took 120 and subtracted 90 from it and said that's 30, so you'd be getting the angle back up here rather than going down here. But you want to go always to the x-axis. And they're kind of telling you on 61 there that finding the trig function values for any non-quadrantal. Remember that a quadrantal angle is anything that lays on the quadrants. In one revolution positive, it's a 90 degrees, 180, 270, and a 360. Those are all quadrantal. So if you have non-quadrantal, and then they tell you if theta is above 360, or if it's less than 0, then what you want to do is convert it back to a 0 to 360 degree angle, the coterminal angle. So like if you had 700 degrees, well, what you'd want to do is find out where 700 degrees, its coterminal angle in the first 360 degrees. So you'd subtract 360 from 700 until you get an angle, what? Between 0 and 360. Then you can figure out which quadrant you're in, and then you can figure which one's your reference angle. Does that make sense? Otherwise, it's pretty hard to figure out which quadrant you're in if you have something, an angle above 360 degrees, or if you have a negative angle. You can usually figure out which quadrant you're in, a negative angle, if it's a negative 360. They're actually telling you always to convert to 0 to 360, because then the quadrant 1 is going to be 0 to 90, quadrant 2 is going to be 90 to 180, quadrant 3 is going to be 180 to 270, and 270 to 360 is going to be quadrant 4. If you run in a negative and you get it between 0 and 360, you see that quadrant 1 is going to be what? A negative 270 to 360. Make sure that if you reduce it to a negative 360 degree, something between negative 0 and negative 360, that you understand your quadrants are backwards. You understand what I'm saying? Because if you got it between 0 and 360, then 270, 360, you're in quadrant 4. But if you have it between 0 and a minus 360, then 270 to 360 is up in quadrant 1. And you can figure out which quadrant you're in. You can figure out your reference angle if you get it either as a positive 360 or negative 360. But if you do a negative, remember that turn those quadrants around, that you know where you're at. And the reason they're suggesting that you always make it an angle between 0 and 360 is so that you don't have that, you don't have to do that, think about it different if it's negative. And then it says find the reference angle, and that's just always to the nearest x-axis, find the trigonometric function values for the reference angle. And then you will put the appropriate sign depending on which quadrant you're in. And that's just the standard practice is that whatever the x, y values are, the x is associated with cosine and the y is associated with sine in terms of plus minus. All right. Then what we're going to do is we're going to look at exercises on page 63, that section 2.2 says match each angle in column 1 with its reference angle in column 2. So we'll go around the room, and who wants to start? Chris in front or Corey in the back? Corey? Corey, number 1. So what is the reference angle for 98 degrees? Okay, so Corey said that 98 degrees I'm up here, right, in this quadrant, and he subtracted it from 180 and got 82, right? Number 2, Greg? Which quadrant are you in? 1, 2, 3, or 4? 3? Everybody can't see your fingers, so. Okay, and then, so he got 32 by doing what? Subtracting 180 from it, because he's down in quadrant 3, correct? All right. Are you ready, Lucas?
Yes.
Okay.
Go ahead and guess on this one as in quadrant 3.
Okay, so 135, you're greater than 90, or this 270, you're in here, quadrant 3. So what are you going to do?
I'm going to go from the 0 line and go backwards to get to there. And then I'm going to subtract 135 from 270.
270 would be, negative 270 would be up here. And positive 270 is over here. If you're in this quadrant, you want to go 180 minus 135, right? Right? Okay. All right, so it's going to be what, 45?
Yeah.
So notice, and you won't put a negative or positive on the 45, it's just 45. Now if you put 135 as a positive angle, what would be the positive angle? 135. If you had 135 and you had the positive angle for 135, what would it be? If this is 135 negative, this is what you got is a negative 135. And what I'm asking is, if you did the positive angle, what would you have here? That'd be a reference angle. But I'm saying, what's this angle right here? Okay, so what? Yeah, it'd be 225 because it'd be this 135 and you have to subtract it from 360. See, 360 would be a rotation. Clear to here, you're coming back 145 degrees. So this would be 225. That would be the coterminal angle between 0 and 360. It still puts you in the same spot. It still puts your reference angle 45. Okay, I'm going to pick on you with this. What is 45 degrees? What is the sine in that quadrant of 45 degrees? The reference thing is sine of 45. So what are you going to put? Is it going to be positive or negative? The answer. Okay, so what you're doing is you're going to say my reference angle is 45 degrees, and then in this quadrant I'm going to have a minus in front of it, and then 45 degrees is going to be what? Yeah, you do. Go back to Q1 on page 54. You see, there's your reference angles, right? We're talking sine. So what sine of 45 degrees is what? Okay, so it's the square root of 2 over 2, and it has a negative in front of it. That makes sense. That's all. I'm making you follow through, Lucas. I'm not letting you off the hook. Yeah, okay. All right. You can beat me up after class if I make you embarrassed in class. But I used to be able to run pretty fast, but I'm pretty slow. I'm old. Okay, Tyler. Okay, so it's going to be the reference angle is number 4 is negative 60, isn't it? So negative 60, we're down here in this quadrant. So what's now you're guessing. 300 is you're telling me the coterminal angle.
Right.
Good. Yeah. Okay. I know I'm asking for a reference angle. Okay. So what? No. Just think. Just think. Fast. Calm down. Take a deep breath. Just look at this. This is a negative 60. 60. Negative, right? You said the coterminal angle between 0 and 360 is 300, right? Now, I'm asking for the reference angle. And the reference angle is always the angle between the terminal side and which axis? It's going to, the terminal side and the x-axis. What is this angle right here? Your mind is just doing all this, jumping all over the place. You see, it's always back to the x-axis from the terminal side. And I'm just showing you what the different things that you were telling me. Yeah. The closest x-axis and the terminal side. And that's this terminal side in this quadrant. This is the closest one. If I'm in this quadrant, the closest x-axis is back here, right? If I'm in this quadrant, if this dashed line is up in this quadrant, then the reference angle is here. Okay. All right. So the next one, number 5, says 750 degrees. Now, James, what's going to be our process? What do you tell me what you're doing?
You want to subtract 360 to try to get the.
Okay, get an angle between 0 and 360 by subtracting 360s, right? So if we subtract one 360, no, are we between 0 and 360? So do it again. And then our reference angle is?
To get you, you're at 30, you want to get back to X, it's just another 30, right?
Okay, now this, what we're saying is that our terminal side is 30 degrees, correct? So the reference angle is 30. That's exactly right, right. So do you see what he did? He subtracted 360s until he got an angle between 0 and 360. Then he figured out which quadrant is he in and where is the terminal side and the closest x-axis. What is that? Now, if that terminal side would have been over here, then he would have done what? He would have taken the angle that he had and subtracted it from 180, right? If that terminal side would have been down here, then he would have taken that angle and done what? Subtracted 180 from it and got the angle back here. Right, James? Yeah. So, okay. Chris, I should say Chris Sharp, because you're getting out of it. Yeah, no. Okay. I'll let you do. Yeah, 480 degrees. What are we doing?
Minus 360 or 360 minus.
Well, no, you were subtracting 360. That's right.
1280 minus 360. 120. That's in the second quadrant.
Okay. So we're up here. And technically what we have is we have this thing that went this way. And then we said really what it is 120. No, reference angle is going to be where?
180 to, or 120 to 180 is 60 degrees.
Okay, so you're measuring this, right? Okay, we'll go until we stump you. Tell me what the cosine is for that 480 degrees. The cosine of 480 degrees is equal to what?
1/2.
Okay, because the cosine of 60 is 1/2, right?
And
But is the cosine of 480 1/2?
is 60 degrees equal to 480?
Now what am I looking for? I'm looking for a sine. In this quadrant, the cosine is going to be what? Positive or negative?
Negative.
Negative, and the sine is positive. Now, we found out that the cosine of the reference angle is 60, but the cosine of 480 is going to be what? Cosine of 60 is 1/2, but the cosine of 480 is going to have to be what?
Is it 1 and 1 here?
No, you got to put the minus sign in front of this.
Oh.
Is that, do you see that? That's what the quadrant will tell you, the plus minus that you're going to have. The reference angle is going to tell you the value. Tyler, you wrinkled your forehead. Do you get it?
Can't see what it is more. Mostly just because I can go to just
Anyone else have? Does everyone else? How many get it? Devin? Devin is a slow riser there. Okay. Well, notice that the reference angle is going to give you the value. The quadrant is going to give you the plus minus. And then the reference angle is always to the closest x axis from the terminal side to the closest x. Okay. So let's look at Chris Jensen, do 13 on the next page there. You see that it's going, and all I really care about is that you get sine and cosine. So it's 120 degrees. And they have given you sine, right, of theta is that square root of 3 over 2. Now, can anybody tell me, Chris, tell me this. How did they do that?
So we have 3 over 2. Well, they're in. So the second quadrant, so they take 120 and subtract it from 180, that's 60 degrees.
All right, everyone good with that?
No, hold on, say it again. It's
Say-
120 degrees, so the terminal angle, the reference, is 120 minus 120, you get 60. So, and that's why you're getting square root of 3 over 2. Right? Yeah, in special angle function, so the cosine you can 1/2.
No, yeah, and the cosine is going to be, so the cosine of this 120 is going to be 1/2, but what do we have to put out front?
The cosine should be positive, the sine should be negative in the third quadrant.
Isn't this the second quadrant?
Or second quadrant.
Second quadrant has,
X is negative, so sine is negative, or the cosine is negative. So it would be negative 1/2. That's what you mean.
okay, 120 was the angle, the reference angle was 60. Everyone good with that? Then the cosine of 60 is 1/2. We're in the second quadrant, and the second quadrant, the x value is negative, and that's the one that's related to cosine. So it's a negative. Okay, do you see that the plus or minus for the x, y values in the different quadrants is actually the sign that's in front of the cosine sign. Remember way back in the first chapter, what was cosine in terms of a point? It was x over r, right? The sign was y over r. So the plus minus for the cosine sign is going to be as an ordered pair of x, y of what its signs are, it's going to be cosine sign. I'm looking. I want you guys all to shake your head. Yes, you get it, because this is important, because you go reference angle, and then you get the sign for the value of that reference angle. Good?
Yeah, let's try another one.
Okay, so let's just go on down. You know, obviously 10, 11, 12, the reference angle and the angle's the same, right? And they're all in which quadrant? First quadrant, so they're all plus plus, right? Now I'm not going to do tangent, cotangent, secant, cosecant, because tangent is what? Sine over cosine. Cotangent is the inverse of the tangent. The secant is going to be what? What is it? 1 over cosine or 1 over sine? 1 over cosine. And then the cosecant's what? So if you know sine, cosine, you got the rest, right? And for tangent, if you're in the second quadrant, because the sign, if you're looking for what do I put plus or minus in front of it, you say the x is minus, the y is positive, so it's gotta be negative, right?
Well, with 13 units and your bar, and you have engine, which is your Y value, whatever value you're missing. Your S value must be over 1 because there's no after 100, so then can you just get 100? At least if it's giving you the tangent.
Yeah. What you missed when you were gone, Tyler, is that we deal with, notice all these angles have reference angles that are either 30, 45, and 60.
Right.
And those were, on page 54, those were common angles. So we're dealing with just the common angle. So, you know, like you're going back to the first chapter where it said it was x over r and you had to find, you know, what. It's the same thing, but what we're doing is we're trying to go to a point where we use the common angles, and we know that we don't have to go back, clear back and be able to figure them out. We know that, and we know that, you know, sine starts out at sine of 0, it's 0 degrees, sine of 30, it's 1/2, sine of 45, it's square root of 2 over 2, sine of 60 is the square root of 3 over 2, and then sine of 90 is 1, and then cosine just goes backwards. That's the common one. Yeah. Okay, so let's do what James wanted to look at. We're looking at 14. So we're at 135. So where do you want me to, where am I going to draw the angle at 135? Okay, I'm going to draw it, and it's going to, something like that, isn't it? 135. So if I'm figuring out sine, cosine, and when I'm doing 135 degrees, what do I have to do first? I have to calculate what? And the reference angle is going to be what?
180 minus 145.
Okay, so it's 180. And that's going to give me this angle, right? Which is what? 45 degrees. Now then, I'm going to do sine. So sine then of 135 degrees equals, okay, it equals the sine of 45 degrees with what plus or minus out in front? Plus. Because the y value is plus in that quadrant, right? So it has a plus. So it's going to be plus the square root of 2 over 2. So that'd be plus square root of 2 over 2. Now, the cosine of 135 degrees equals plus or minus negative cosine of 45 degrees, which is negative square root of 2 over 2. So this then would be a negative square root of 2 over 2. There's two things you have to do. The quadrant tells you whether it's plus or minus, and then the reference angle tells you what the value is. Right. Pretty good, right? Well, so you see that where are you going to turn into the third quadrant? Which one of those are third quadrant angles? 16 is 17 third quadrant angle. What does it have to get bigger than to be a fourth quadrant? 270, less than 360. And then you do the same thing. You say, is it plus or minus? Depends upon the x, y. And remember that it's cosine sine. It's not. usually the thing that'll horse you up when you do those ordered pairs, you know, for X, Y, you'll put sine cosine rather than cosine sine. Understand what I'm saying? Because the normal way we talk about stuff is sine cosine, but if you're looking for what is it plus or minus, it's the reverse order. Do you follow what I'm talking about? All right. So now let's go down and look at 18 through 35. Notice it says find exact values. Now, when they say exact values, is leave it in square root form. If you give me a decimal and I've said exact value, that's not an exact number. And I'll check it wrong. You want to be accurate, and most of you are going to be going into accuracy. Do not use decimals, because if it's non-repeating, non-terminating, or if it's a repeating, non-terminating, you're going to have to end that decimal someplace. When you end it, you rounded it off. But if you take the square root value and plug that in your calculator, it'll be exact, because it will take it out as far as it has the power to do it. But if you force a termination point, then you've rounded it. You haven't let the calculator do its accuracy. See, if you multiply square root of 3 times 2, and then you do the square root of 3, and then if you take the square root of 3 and then round its decimal off, you're not going to be as accurate with the decimal equivalent. Understand what I'm saying? And when you go for accuracy, if you want to be as accurate as your calculator can get it, is you put square root of 3. And you put 22 over 7, you don't put 3.1416, because you just rounded that off, right? So just most of you are going to go into fields that accuracy is going to be important. So, and I'm not going to get into how you round off, because if you do round off, your person that you work for, company you work for, will have their own methods, or your class in your program will say, this is what we want you to do. Notice we want all 6 trigonometric functions. What's the first thing we're going to do with that thing? Well, 720 is the most 360s you can get out of it, isn't it? Because that's 2 360s. That's what you told me first of all, didn't you? Subtract 720, and what you did is you said the most 360s is 2. 2 360s is 720. So I need to subtract that out. Okay. And that's first quadrant, so the reference angle is 30 degrees. And you're going to be what? The X and Y values are both going to be positive. So you don't have to worry about signs, right? I mean, in terms of plus minus. So now all you have to do is say the sine of 750, and then we'll go cosine of 750. So the sine of 750 is actually the sine of 30, which is 1/2, right? The cosine of 750 is cosine of 30, which is, okay, square root of 3 over 2. The tangent of 750 is tangent of 30. Okay, it's sine, it's this one, it's actually 1/2. If you only know sine and cosine, you do this, or else you have to look into that table. But so you invert and multiply, then it's 1 over square root of 3, which you can't leave it. Then you have to rationalize the denominator, and you get square root of 3 over 3. Is that what you get? What I did here was I knew that tangent was sine over cosine, so I took this one over this one. Now cotangent, 750, is going to equal, and what I would do is I would say, is it 1 over the tangent of 30? And that's simply inverting this thing right here, right? So it's a square root of 3. And then what's related to sine in terms of secant, cosecant? Cosecant. Sine and cosecant are related, right? Cosecant of 750 is 1 over the sine of 750, and that's 2, right? It's the invert up here. And the last one is secant 750 is 1 over cosine 750. And you look back up here, and that's the invert there, 2 over the square root of 3. Then you have to rationalize, right? Which is 2 square root of 3 over 3. Now the reason I'm doing all this stuff is because I want you to get used to thinking about the identity. You know, what is identical to it, and then see that all you got to really know is sine and cosine. So in terms of what you put in your head, what do you have to put in your head? If you're talking about those angles 30, 45, and 60, you just got to put sine and cosine in. And then those identities, you got to learn them. And learning the identities are going to be useful because if you go further in mathematics, what's going to be beneficial is to be able to translate trig functions into other trig functions. And those identities are going to be useful for you. So, I'm trying to get you prepared to go into calc and all of that stuff.
Did it once. Couldn't remember it all.
Well, you know, if you learn what the simple things are to learn, so you don't have to put all that junk in.
Yeah.
Yes. I mean, that's the way I do it. It's got to be it has to fit a logical sequence. You don't have to miss much, Tyler, before it gets kind of overwhelming, doesn't it?
Well, okay.
Okay.
I just,
Oh, I better.